Hello everyone, welcome to Unacademy. So before starting today's session, I would like to have the input as well as the concurrence regarding the quality of video as well as audio. If it has been perfect, just write perfect over the live chat and then we are going to go ahead. Let me focus over the agenda behind today's video. In past 3 to 4 number of videos, my basic concern was continuity, differentiability and limit test. In the same sequence, probably today is going to be the last class over the limit, continuity and differentiability. That is why a bit higher thinking problem is being taken in today's class. In each and individual question, definitely you are going to learn something new and the concept would be more deeper in compare with the questions which we had taken in last 3 to 4 number of videos. So let me focus over the first question first. The number of questions which I had taken and which I am supposed to take in today's class, they have all come in different gate examination. This has been the first question. Here comes the second question. You yourself would be able to see the function which we have been dealing in today's class is bit complex in compare with the function which you have already dealt earlier. Similarly, this has been the third question. Then here comes the fourth question, fifth and then sixth one, fifth one, and then comes sixth one. So that is what I am saying. In today's class, we are going to take a better questions. So let me go back and straight away hop into the first question. So problem states, which one of the following function is not differentiable in domain? The domain is being defined as a closed interval of -1, 1. The four different functions are being given. They are being x square, x minus 1, 2 and the maxima of x comma of minus of x. So tell me what could have been the best most answer. For the each question I would be giving approximately 2 minutes to you guys and within 2 minutes you had to give the perfect most answer for this given question. So I would start the timer for the each and individual question and let me, yes, so timer do starts for this given question. Read the problem carefully and tell me what could have been the best most answer. Which one of the following function is not differentiable in the closed interval of -1, +1? I want the answer from each one of you. And for the each and individual question, I would be allocating 2 minutes. So 1 minute timer is already been going on. And once the timer gets off, I would start this timer once again. So basically speaking, for the each question, I would be running the timer 2 times. Read the problem carefully and tell me what could have been the best most answer. Read the problem and tell me what could have been the best most answer. I need the answer from each one of you. I need the answer from each one of you. Let me start the timer once again. So the timer had started once again. Read the problem carefully and tell me what could have been the best most answer for this given question. Tell me what could have been the best most answer for this given question. Approximately 20 seconds are been left out for this given question. Anyways, let me come back to this problem. My dear friend, the four different varieties of the functions are been given as an option. Starting 3 number of functions are being a perfect polynomial. And if you have been dealing with a perfect polynomial, the polynomial would always be continuous as well as differentiable in the entire range of x. This has been a polynomial with a degree of 2. This has been the polynomial with a degree of 1. This is the polynomial with the degree of 0. So you need not to give any second thought. Whenever you have been dealing with the polynomial, there would not be any problem with differentiability, virtually speaking, continuity as well as limit. So obviously option A, B and C has been discarded. Now the option D has been the option probably many of us had not been seen earlier. Maxima of x comma minus of x. Anyways, what is x stands for? X is being a straight line which passes through origin and had the slope of unity. Similarly, minus of x is again been a straight line passing through origin and had a slope of -1. We had to take the maxima between these two curves. So what we have been doing, let me focus over this curve first, which has been utterly important. See what I would do now. Let me take this is been x-axis and this is been a y-axis. Let me draw x curve first. The x is going to be a straight line. The x is going to be a straight line with the slope of unity. And similarly, minus of x is again been a straight line with the slope of -1. So let me draw this once again. Yes. Let me change the color. Here I had taken this one. Yeah. Let me change the color and I had taken this one. Yeah. Anyways, if you'll focus over this function, no, one thing has been quite clear. You had to pick the value which has been greater. Either it's been x, either it's been -x. Now, let me take analysis in a different values of x. My dear friend, if you had been standing at x is equals to -2, minus of x is been carrying the worth as plus of 2, and similarly plus of x is been carrying the worth as plus of 2. You had to take its maximum value. Should I be taking -2? Should I be taking +2? Obviously, I would be taking +2. Same goes at -1 as well. At -1, the worth because of plus of x is been -1, and similarly because of minus of x is been +1. So one thing has been quite sure, for all negative value of x, minus of x would be taken as max between x comma minus of x, because the minus of x carries a larger value. But if you go towards right hand side, or for the positive value of x, let's take you had reached to the x is equals to +1. If you'll feed x is equals to +1 at x, it would lead the magnitude as 1, whereas minus x would lead the value as -1. So will you be taking +1 or -1? That solely depends whether the maxima is being taken or minima is being taken. You had to take the maxima. So obviously your point of consideration would be +1, and same goes at 2 as well. So once you'll figure it out what had happened for the negative value of x, this has been your outcome. For the positive value of x, this has been your outcome. And virtually speaking, this kind of curve is already been seen earlier, and this has been a V shape having a slope is equals to -1 for negative value of x, and having a slope is equals to +1 for the positive value of x. So obviously this is nothing but modular of x function. Keep in mind, max of x comma minus of x can also be referred as module of x. This thing must be clear to all of us. And as you know, the cusp is been formed at x is equals to 0. Although within this closed interval, it had been a continuous, but it had not been differentiable at x is equals to 0. So tell me, which had been the perfect most answer? The D. The f of x, which has been a maxima between x comma minus of x, is not been differentiable everywhere in a closed interval of -1 comma 1. The next important thing, rather writing max of x minus of x, if they could have referred minima between x comma minus of x, in that case it must have been minus of magnitude of x. Why so? If they had been referred over the minimum value, so at x is equals to -2, the value would be referred by plus of x. Similarly, at -1, the value would be referred by plus of x. And once you'll go for the positive value of x, the values would be referred by minus of x. So virtually speaking, this becomes minus of mod of x. So this thing must be clear to all of you. The important point which has to be noted by all of us, polynomial. The structure of the polynomial used to be like this. It's been a constant coefficient. It's been the coefficient of the linear part of the polynomial, x to the power of 1, x2, x square, plus x3, x to the power of n, so on and so forth. Just a minute. Rather writing n, I could have written this as x3, where all of the coefficients are being a real number, belongs to the family of real number, and the power of x is always a whole number, in that case the given f of x would be differentiable in an entire region of x, would be differentiable in entire region of x. So at least you need not to have any kind of ambiguity while you have been dealing with the x square. Yes sir, is it been a polynomial? Yes sir, it had been a polynomial with the degree of 2. Degree of 2. Once you'll compare it, definitely they had been falling in the same stature. If we'll talk about the x minus of 1, definitely value of a0 is been minus of 1 and the value of a1 is been 1. Yes, and the remaining term is been 0. So again it is been a polynomial with the degree of 1. With the degree of 1. If we talk about 2, obviously it has been a constant coefficient and the remaining coefficients are been 0. So I would say again it is been a polynomial with the degree of 0. With the degree of 0. And obviously the option D had been a function. This has not been a straight form of a polynomial and the cusp has been formed at x is equals to 0. So by default I can say apart from option A, B, C, the D has been the option which is found non-differentiable within a closed interval of -1, 1. -1, 1. Is that part clear to all of us? Is that part clear to all of us? If you don't believe, let me show you an example. Randomly, I have been taking few different kinds of polynomial and we'll see whether it is being a differentiable or the curve is being smooth everywhere in the entire region of x or not. So let me do one thing. Let me take a calculator and I had been drawing the graph over here. Let me draw a graph over here. X square, definitely. X square, definitely it is going to be a upper facing parabola. But yes, it would be smooth everywhere. If you'll take a polynomial with a higher degree, let's take the degree has been 4. So deliberately I had taken x to the power of 4 and then minus of, I can take 3 of x square, I can say square, and then plus 3. Let me see how they have been looking like. See, this has been the red curve is stands for x square. Is it been quite smooth everywhere? You yourself would be able to see the slope had changed its worth at x is equals to 0, but still there had not been any formation of cusp. That means at x is equals to 0 also x square is going to be differentiable. If we'll take the reference of blue curve, which stands for x square, x to the power of 4 minus of 3x square plus of 3. Somewhere in between -1 to -2 the slope is being changed. Slope is being changed at x is equals to 0 and similarly somewhere at 1, 2. But still if we'll focus over this stature now, the function has been quite smooth. If you'll draw the tangent now, there would be a unique tangent with each and individual function. You'll have a unique tangent at each and individual function, or I can say the function has been proper differentiable. So this thing should be there in your mind from here onwards when we have been dealing with this kind of problem, what I am saying, this kind of problem. So this must be clear to all of us. In the same sequence, I think it's been the right time I should also be moving forward taking the next question as well. What the problem states, consider f of x is equals to 0 when the x is being 0 and x square divided by a magnitude of x elsewhere. Options are being given. Fx is discontinuous everywhere. Fx is continuous everywhere. F does x exist. What does it mean of it? The first derivative of the function exists within the open interval of -1, 1, and similarly the first derivative exists within the open interval of -2, 2. So you had to focus over the 4 different options which are being attached along with this problem and tell me what could have been the best most answer for this given question. Again, for the each and individual question, as it had been communicated earlier, I would be allocating the 2 minutes. Your time starts now. Read the problem carefully and tell me what could have been the best most answer for this given question. A function has been clearly given which carries one number of independent variable, and they had been focused over continuity and the existence of differentiability. Or I should say my basic or more my prime focus has been continuity and differentiability test. Read the problem carefully and tell me what could have been the best most answer. What could have been the best most answer? Again, this problem had come in IIT Delhi's examination probably in 2003 somewhere. So the questions which I have been taking in today's class, those are all questions that had come here and there in GATE examination. Yes. So you can't say, sir, these questions are not been relevant in our GATE examination. Questions are been brought from PYQs, GATE PYQs. Read the problem carefully and tell me what could have been the best most answer. So let me start the timer once again. I would request to all of the students who had not joined our paid course, they must join our paid course, because such a minimal amount you guys are been paying, and in behalf of that minimal amount, such a good content, such a quality content is being catered to you guys. Anyways, let me focus over the Pratigya batch. Actually, the Pratigya batch, the basic crux behind the Pratigya batch, it's been designed for the student who had been aiming for GATE 2024. This many educators are going to take the classes over the Pratigya batch. The classes are already been begun from 15th of December onwards. Whenever you have been opting any of the course, or you have been going behind purchasing any course, the code which you guys had to use is been GA1111. Yes, let me go forward. Anyways, let me focus over the amount of money which you guys are been paying over here. If you get the subscription of 15 month, merely 4,499 rupees you guys have been paying. If you'll go back 2 years back, probably even the one subject has not come with such a minimal amount of price, but within this minimal amount of price, the complete course is being offered to you guys. And if you have been preparing for GATE 2025, obviously the subscription duration must be somewhere such that it must cater your requirement till late of 2024 or beginning of 2025. So obviously the subscription duration must be 30 months, and just 6,499 rupees you guys have been paying. I can say in my time, no, we had to spend such a huge amount, and now I can say with such a minimalistic amount you have been offered such a good content. Yes, this many faculties are going to cater this quality product. And now let me focus over the amount of content which you will be getting if you opt our recorded course. GATE Mechanical, where our mode of communication is been in English. What does it mean of it? Technical words obviously would be communicated in English, whereas the complete concept would be delivered in Hindi. 1360, 1360 hours. GATE Civil Engineering, 1324 hours. GATE Electrical, 1513 hours. GATE Electronics, 1447 hours. And here comes GATE CS and IT, 1134 hours. But the amount of money which you have been paying, see, once you'll divide, no, like 4,000 is been divided with 1,000. 4,000 is been divided with the 1,000 for the 1 hour you have been just paying. How much? Somewhere 3.5 rupees. That's it. And that too, you can see that, or you can watch that video n number of times. Again, whenever you had going ahead with the purchase, or you wants to onboard with us, the code is going to be GA1111. Same. If you have been a student who have been from our southern part of our country, or you have been more acquainted in English, so definitely rather going behind the English course, you could have gone behind the English course. This has been a pure English course. What's been the basic difference? Here our mode of communication would be completely English, as I had been taking the class, where all of the feeling, even the guidance, the mistakes which we guys have been making, all of the communication would be made in English only. See, this has also been our recorded course. For mechanical, 700 plus hours. For civil engineering, approximately 1,000 hours. For electrical, more than 1,000 hours. For electronics, 962 hours, and for CS and IT 968 hours. What else you want? Anyways, you can call us for getting better deal as well as knowing about our product into the better way. Let me come back. Let me come back and focus over this question once again. So tell me what could have been the best most answer for this given question. My dear friend, once you'll focus over this question, this function is being valid everywhere except x is equal to 0. And the worth of the function is being null at x is equal to 0. And in this problem, they had been focusing over the continuity and differentiability within a certain open interval. So I think it would be better if we will be able to draw this curve. What I'm saying, it would be better if we'll be able to draw this curve, because visually if you are able to understand how the curve looks like, easily you will be discussing about the continuity as well as differentiability. My basic focus has to be the curve for this given function. What I have been doing, just have a look of it. What has been my approach? Here I have taken, just a minute. Here I had taken x-axis. What had happened? Just a minute. Here I had taken x-axis. So here it has been x-axis. This has been x-axis, and here comes a y-axis, or I should say this plane has been a xy plane. This has been the x-axis and this has been the y-axis. The worth of the function is been clearly given along with this problem, and that is been 0 at x is equals to 0. So at x is equals to 0, the dot would be framed at the magnitude of 0. Most of the student might be getting confused at this function. My dear friend, x square could have been written as magnitude of x into magnitude of x. Why so? X square would always be positive, and the power of x is being 2. Even the mod of x and mod of x would always be positive, and once you multiply them together, definitely again the result is going to be what? Power of 2 only. Why I did so? Because now the numerator and denominator had a common factor, and we can fetch the outcome easily, and this has been mod of x, or I can say it has been V-shaped structure, making cusp at x is equals to 0. For the negative value of x, the slope is been -1. For the positive value of x, slope is been +1. So what we have been doing, we have been drawing the mod of x. Many of the times you might have seen this structure. This has been kind of this. Yes. This, and just a minute. This. And you guys must have noticed one thing. The magnitude at x is equals to 0 would not be decided by this function. So that is why this function is making a hole over here. But the hole is been filled by this dot. So tell me what had been the structure of this given function. The function had been continuous in entire region of x. Either you go towards a very larger value of x towards left hand side or towards right hand side, the function remained continuous. Even it remained differentiable because the function has been quite smooth. Only and only the point of problem or the point of deficiency is been x is equals to 0. The cusp has been framed, and as the cusp is been framed, the function would be non-differentiable at x is equals to 0, and apart from x is equals to 0, it is going to be differentiable and continuous everywhere. So what has been the outcome out of it? So except x is equals to 0, the function is differentiable everywhere. Differentiable everywhere. Yes, and similarly I would say for the entire x-axis, the function is being found continuous even including x is equals to 0. So read these 4 different options which are being attached along with this problem and tell me what could have been the best most answer. Fx is discontinuous everywhere. No, this is a worst statement which we could have framed, and any of the student had gone behind this statement. No, so definitely you have to look behind your concept thoroughly. Fx is continuous everywhere. Yes, fx is being a continuous everywhere. F does x exist in open interval of minus 1 comma 1. No, it exists everywhere except x is equals to 0. As the cusp is been framed at x is equals to 0, you will not be able to draw a unique tangent at this point, and hence the first derivative would not be able to identify it. And similarly, first derivative of the function do exist within a open interval of minus 2 comma 2. No, not at all. Again, it cannot be. It cannot be. So may I know what had been the best most answer? The B is being the best most answer. So what had been the beauty behind the two questions which we had taken? Until and unless you are not able to understand the max of x minus of x, it stands for which kind of function, you won't be able to crack this problem. Same goes with the second question as well. As if you are not able to figure it out, x square divided by f modulo of x is going to be which kind of the function, again you will have problem. Otherwise mathematically you could have gone behind the calculation of continuity. Left hand limit, right hand limit. If left hand limit is being same as right hand limit, the limit do exist, and if its worth is being same as f of c, the function is also been a continuous function. And same goes with the differentiability test as well. So I feel the second should also be understood to most of us. In the same sequence, I think has been the right time. I should be taking the next question as well. So let me start the timer, and as it had been communicated earlier, for the each question I would be providing 2 minutes. So the timer starts for you guys. Consider f of x is equals to x plus lambda when the value of x is being lesser than 3. What does that mean of it? That means the worth of the function would not be decided by x plus lambda exactly at x is equals to 3. No, it would be decided just before 3. And the worth of the function is been 4 precisely at x is equals to 3, and for x greater than 3 the worth of the function is been 3x minus of 5. Fx is continuous at x is equals to 3, then lambda will be. The 4 different options are being attached along with this problem, and they are been 4, 3, 2 and 1. 4, 3, 2 and 1. So I would request to each one of you read the problem thoroughly and tell me what could have been the best most answer. Read the problem thoroughly and tell me what could have been the best most answer. So let me start the timer once again. So timer starts once again. The timer is started once again. Tell me what could have been the best most answer for this given question. What could have been the best most answer for this given question? My dear friend, if you'll focus over the 3 different functions which are been given along with this problem, x plus a lambda, it is been a linear polynomial or the polynomial with first degree. And same goes with the 3x minus of 5. Again, it has been a linear polynomial or the polynomial with the first degree. As it had been seen earlier, any kind of the polynomial would be differentiable in an entire region of x. No doubt about the differentiability, continuity and the existence of the limit. It would have all of 3 tests done. But as the change over it's been taken place at x is equals to 3, so definitely x is equals to 3 is going to be my area of concern. Did you really understood what exactly I wanted to communicate at this point? As far as x plus lambda is being concerned, if x plus lambda is being defined in an entire region of x, definitely you don't have to worry about the differentiability, continuity and limit existence. As being a perfect polynomial, it would be differentiable everywhere, and as it is been differentiable, it would have continuity as well as existence of the limit. Same goes with the 3x minus of 5. Even 4 is being a 0th degree polynomial, so here also there would not be problem at all. But why the problem had been taken place? Because the change over between the function is being taken place at x is equals to 3. So if you guys are be able to manage the so at x is equals to 3 everything is going to be fine apart from x is equals to 3. Either you go towards right hand side, either you have been coming towards left hand side. So my basic concern has been at x is equals to 3. Agreed. It had been clearly seen earlier. What I am saying, it had been clearly seen earlier. The function is going to be continuous at test point. Here the test point is being x is equals to 3. If the left hand limit, or I should say the worth of the function just before the test point, or limit at x tends to 3, and it has to be very same as the worth of the function just after the test point, and has to be very same as the worth of the function at the test point itself. At the test point itself, either you could have calculated f of 3 minus 3 plus using left hand limit or the right hand limit, or the short trick is already been communicated earlier, so you could have taken the help of the short trick itself. Anyways, if you have been willing to calculate the worth of the function just before 3, which functions to be used? Obviously I had to use the first function, because this function is being defined only for the reason of x, where the x has been lesser than 3, and 3 minus is being the value of x just before 3. So obviously this function is going to identify the worth of function at 3 minus. Similarly, the worth of the function at 3 plus would be identified by 3x minus of 5, and the worth of the function at x is equals to 3 is clearly given as 4. So let me plug those data. So here what had been happening, x would be fed as 3 plus lambda. Many of the students would have a next doubt, so why don't we take this as a 3 minus? Actually, what does it actually mean of 3 minus? The value is being very near to 3, but as we have been approaching from left hand side, I could not reach to 3, and I had stopped myself just before 3. I could have called this as 2.9999 or 2.9 bar, or I should say it is been tending to 3 from left hand side. So 2.99 bar could have been taken as 3 only. So this has been 3 plus lambda. And same goes with the f of 3 plus. Now as 3 plus exists x is equals to 3 onwards, so obviously 3x minus of 5 has been the function which would be looking after this worth. So what we would be doing, again the x has to be fed as 3 again minus of 5, and the worth of the function at 3 is already been given as 4. See what had been happening, 3 3s are 9 minus of 5, that has been already 4. So at least right hand limit and the worth of the function at test point are being same. Just we had to ensure even the left hand limit should also fall in the same category. So what I would do, I would compare 3 plus lambda with 4, and the lambda value is going to be 4 minus of 3, and that is going to be 1. Agreed what I am saying? Did you understand what exactly I wanted to communicate through this problem? So what I mean to say, if the first function is being x plus 1 and the remaining function remains same, by default the function would remain continuous in an entire region of x. If you don't understand graphically, you can understand this problem in better way. So I am going to draw the two different linear equations, x plus 1 3x minus 5, x plus 1 3x minus 5. So let's take this as a x plus 1, and this has been 3x minus 5. So here comes 3x minus 5. Let me draw this down. You yourself would be able to understand. Yes, this one. And let me go back into my problem. This has been my problem. Yeah. See, the changeover is being taken place at x is equals to 3. Before x is equals to 3, the function was identified or dominated by x plus lambda, where the lambda is being taken as 1, and from x is equals to 3 onwards it's been taken over by 3x minus of 5. So let me go back. See, 3x minus of 5 is being drawn in blue color, and x plus 1 is been drawn in a red color. X plus 1 is been dominated or is been identifying my function for x is equals to 3 before. So obviously I can rub this out. This reason I can rub this out. I can rub this out. This reason, which one? This one. This one. And this red curve has been rubbed out for the x greater than 3, and you yourself would be able to understand there had been the two straight lines. The first one has been the red, which had been the outcome from x plus 1, and similarly the second one has been blue, which had been outcome of 3x minus of 5. The changeover has been taken place at x is equals to 3, but what had been the beauty behind this problem? There had not been any discontinuity over the function. And even once you'll focus over the function, no, the red curve as well as blue curve, they were making a whole at x is equals to 3. But the dot which had been fed at x is equals to 3 had also the magnitude as 4. So you can see the result which I have wanted to communicate over has been, if you had been approaching the function from left hand side and you had stopped yourself just before 3, the worth of the function is to be raised or to be asked from this red curve, or I should say from x plus 1, and the worth which we have already calculated, and the worth is been found to be 4. And similarly, if you have been approaching x is equals to 3 from right onwards and you had stopped yourself just before 3, or I should say just after 3, so f3 plus had also been the same value as 4, and they were made a whole at this point. But even it is also been clearly given the worth of the function precisely at 3 is also been 4. So left hand limit is been same as right hand limit, and it's also been same as the worth of the function at x is equals to 3. And as all of the requirement of the continuity of a function has been met, by default it is going to be a continuous function. It is going to be a continuous function. So f of 3 minus is been very same as f of 3 plus, and it is also been very same as f of 3. F of 3. Could you really understood what exactly had been happening with this question? Obviously. So I think it's been the right time. I should also be moving ahead, taking the next question. Let me go back. So this question is also done from my side. So here comes the next question. Consider the function f of x, which is being defined as the absolute value of x in the closed interval of -1 to +1 at the point x is equals to 0. F of x is continuous and differentiable, non-continuous and differentiable, continuous and non-differentiable, neither continuous nor differentiable. Tell me what could have been the answer for this given question. And this kind of the questions are being taken in many different cases. So I expect the student who had been attending my lecture in a daily basis, probably they could have reached the answer till now. They could have reached to the answer till now. Tell me what could have been the best most answer. What could have been the best most answer? Read the problem carefully and tell me what could have been the best most answer. So let me do one thing. Let me take a plane which contains the two axes, x-axis and y-axis. Here comes the x-axis and here goes the y-axis. And if you'll focus over the function magnitude of x, it is going to be a v-shaped curve which will make a cusp at x is equals to 0 and would have a slope is equals to -1 for the negative value of x, and would have a slope is equals to plus of 1 for the positive value of x. This has already been seen earlier. So let me draw this down. The structure is going to be kind of this. This is going to be kind of this. Yes. And now just by taking the reference of this graph, I may be able to communicate which kind of options endorsing my requirement. Is it been continuous? Obviously, nowhere the pen has been lifted, nowhere this curve has been disrupted. So obviously it is going to be continuous. Is it been differentiable? No, sir. At x is equals to 0, the cusp is been framed. The cusp is being framed at x is equals to 0. That means the unique tangent cannot be drawn at x is equals to 0. So obviously it won't be differentiable, at least at x is equals to 0. So option A is been discarded. Non-continuous. No, my dear friend, it had been continuous in an entire region of x. This has also been discarded. Is it been continuous and non-differentiable? Yes. The better answer must have been it has been a continuous in entire region of x. It has been a continuous in an entire region of x. Sorry, if it has been a continuous in an entire region of x, and it has been a differentiable in an entire region of x except x is equal to 0, because there have been infinite different points where the function are been found to be differentiable except x is equal to 0. Yes or no? Yes, sir. So I would say only one thing. So there's been a continuous in an entire region of x, and it had been found differentiable at x is equal to 0. So the C is going to be the best most answer. This has been the graphical way to solve this problem. I can say this has been the method 1. Yes. There could be the different method as well. Mathematical method. Mathematical method. The function f of x that had been written as a magnitude of x could have been splitted into two parts. Magnitude of x has been defined as a minus of x for x lesser than 0, and it's been defined as a plus of x for x greater than 0. From where the magnitude of x has been classified in the two different zones is already been discussed in an earlier class. So the student who have been continuously attending my classes, they must have a little bit idea about it. Agreed what I'm saying? But as you can see, once you'll feed x is equals to 0, even the minus of x and plus of x is been leading the same value which is being 0. So I could have taken this as equal sign as well. Equal sign as well. What I would be doing? See, minus of x is being a first degree polynomial. It is going to be continuous everywhere. Plus of x is again being a first degree polynomial. It is going to be continuous everywhere in entire region of x. But only and only the point of concern is been a change point. The change point is been at x is equals to 0. And once you'll feed x is equals to 0 in first as well as the second equation, one thing has been quite sure, there had not been any disruption. There had not been any sudden change. So the function is going to be continuous undoubtedly. So at least continuity wise, this function is being continuous in an entire region of x. In an entire region of x. Any point, the problem is being only and only differentiability, and the test point is going to be at x is equals to 0. So what I would do, I would perform the left hand derivative, or I would calculate the differentiation of the function at x is equals to 0 minus, and that would be called as LHD. And similarly, I should perform just after x is equals to 0, which I should call as a RHD. Anyways, for performing left hand derivative, I need to take the derivative of the function at just before the test point, and which is being 0 minus. And here comes df over dx just after x is equals to 0, which is being 0 plus. Just before 0 minus, or I should say for the negative value of x, the function is being identified as a minus of x. So the differentiation has to be taken place for the minus of x. And similarly, the differentiation for x is equals to 0 plus. That means the differentiation has to be taken for the x only. Let me do the differentiation over here. So minus of x has been differentiated, that stands for minus of 1. Anyways, there had not been any place to keep x is equals to 0 minus, so leave it about. And same goes with the df over dx as well as, and here it becomes 1. And you can see very well, there had not been any match over their slopes. The slopes are being mismatched, or I should say, there had been the sudden change in slope. The slope had not been smoothly decaying to 0 and then it had been increasing, or it had not been decreasing and then suddenly it had been increasing. No, that had not happened, and you yourself would be able to see the slope has been continuous everywhere. And from here onwards, the slope is been abruptly changed to positive. So the slope is been -1 everywhere, -1 everywhere, and suddenly it had raised to plus of 1. And that's been the problem with this question, that the sudden change in slope will not allow to make a smooth curve. And if the curve is not been smooth, you won't be able to draw a unique tangent at the point of interest, and hence the function would be non-differentiable. The function would be non-differentiable. Agreed what I'm saying? So I think it's been the right time. I should also be going ahead with the next question. For this question also, I would be giving approximately 3 minutes. Read the problem carefully and tell me what could have been the best most answer. Read the problem carefully and tell me what could have been the best most answer. So let me start the timer now. So here starts the timer. Yes. Read the problem thoroughly and tell me what could have been the best most answer for this given question. Which of the following function is continuous at x is equals to 3? Anyways, the function will be continuous at x is equals to 3 only and only if there had not been any pole at x is equals to 3. If the pole is been framed or the found at x is equals to 3, there would be the point of discontinuity at x is equals to 3. So while doing this kind of analysis, this thought must be there in your mind. There should not be any there should not be any pole at x is equals to 3. If you don't understand, let me take an example. Deliberately, I had taken a function f of x is equals to 1 upon x. If we'll focus over its pole, so the roots of its denominator is being called as a pole. So x would be compared 0. So x is equals to 0, or I should say 0 itself is the pole. So it had been communicated earlier. So probably 1 upon x is going to be discontinuous at its pole, or I should say the 1 upon x is going to be discontinuous at x is equals to 0. For that, what I would do, I would take a xy plane. The x-axis and y-axis has been drawn over here. Here comes x-axis, here comes y-axis. My dear friend, if the value of x has been plugged a positive real quantity, 1 upon x is also going to be a positive real quantity. If the value of x is been plugged as a negative real quantity, the value is also going to be a negative real quantity. Plus, plus, minus, minus. So once you'll plug the value of x as plus, the value of y is going to be plus. So obviously in first quadrant, when the value of x has been plugged negative, the value of y is also been negative. It has been third quadrant. So one thing has been quite sure, 1 upon x is going to be a curve which will take its existence only and only in first as well as fourth quadrant, third quadrant. Once you'll feed x is equals to 0, 1 upon 0 becomes infinity. But if it is been 0 plus, it is going to be plus infinity. When it is been 0 minus, it is going to be minus infinity. So I would say just after y-axis or just after x is equals to 0 axis, that is being 0 plus, the worth of the function would be taken as plus infinity. It would shoot towards the upper side, and just before it would shoot towards the lower side. And as the value of x would be keep increasing, either you take plus infinity, either you take minus infinity. A largest value or the very large value, massive value is being divided with 1. Definitely the result is supposed to be 0 only. So what's been the conclusion over here? What's been the conclusion over here? So once you'll focus over its result, no, the result has been quite known. What has been that? What has been that? The result is been kind of this. And this has also been called as a rectangular hyperbola. This structure has been called as rect hyper. You might have seen, although it is looking smooth, but it resembles a rectangular structure, rectangular hyperbola. This resembles a rectangular hyperbola. And at x is equals to 0, obviously it had found discontinuation. My dear friend, if we'll talk about the continuity, see, this is being a 0th degree polynomial. It is going to be continuous in entire region of x. Same goes with this, same goes with this. So as far as the individual polynomials are being concerned, they have been found continuous. But at the change point, there could have been a sudden difference or sudden jump. So that is why the discontinuity must have been framed. So what I have been doing, I would check only and only at the test point, and the test point are being x is equals to 3. Once I'll feed x is equals to 3, 3 plus 3, that is been 6 divided by 3, that is been 2, 3 minus of 1, that is been 2, and even the worth of the function at x is equals to 3 is also been 2. So I should say, if we'll focus on the first question, if I will focus over f of 3 minus left hand limit, f of 3 plus, and worth of the function at f of 3, the worth is to be calculated from this 3 plus 3 divided by 3, That is been 2. That is been 2. Similarly, f of 3 plus has to be calculated through x minus of 1. That is been 2, and even that is also been 2. So yes, this has been continuous. Now if we'll focus over the b. See, the 8 minus of x has been a function which had been defining this given function, or 8 minus x is been defining f of x everywhere except x is equals to 3. So once I'll feed x is equals to 3, x is equals to 3, the result is been 5. Result is been 5. So you can say f of c minus as well as f of c plus both had the worth as 5, but the worth is not been very same. So yes, this has been discontinuous. So I should say this has been discontinuous and this has been continuous. Let me take the reference of this as well. Now 3 again, we'll be feeding 3. 3 plus 3 has been 6. Yes. And similarly 3 plus 3, that has been 6, and once you'll feed x is equals to 3, that becomes 8 minus of 3 as 5. So obviously this has also been a discontinuous. This has also been a discontinuous, and at x is equals to 3, this would also be a discontinuous. Which one of the following function is continuous at x is equals to 3? Probably this could have been a better question if they must have designed this problem in a form of MSQ, and they must have asked which of the following is R, being a discontinuous function in an entire region of x. So obviously the B must have been, C must have been, and D must have been your answers. So B, C, D must have been the better answer, or B, C, D must have been a better question which a person could have been designed. Okay, this question is already been taken now, probably. Yeah. A well designed question. Modulo of sine over 2 pi x divided by of L. At x is equals to 0, the function is continuous and differentiable, non-continuous and non-differentiable, non-continuous but differentiable, continuous but not differentiable. Read the problem carefully and tell me what could have been the best most answer for this given question. Read the problem carefully. Again, for this given question, I would be offering 2 minutes. Like exactly in 2 minutes, you guys must be able to crack this problem out. Your timer starts now. Read the problem carefully. Read the problem carefully and tell me what could have been the best most answer for this given question. The timer is already clicking. So read the problem carefully and tell me what could have been the best most answer for this given question. Tell me what could have been the best most answer. Read the problem carefully and tell me what could have been the best most answer. Anyways, forget about the sine of 2 pi x divided by of L. Let me focus over the sine of x first. Let me go back into my calculator. So here comes the sine of x. Let me remove this two functions which we had used earlier, and let me take this as sine of x. See how the sine of x would look. This is going to be sine of x. This is going to be sine of x. Anyways, we are now not been focusing over the sine of x. We had been focusing over the magnitude of sine over x. We had been focusing over the magnitude of sine over x. So, may I know what would be the difference between sine of x and the magnitude of sine over x? See, whenever the worth of sine of x is been positive, even if you take its magnitude, it does not make any sense. When the sine of x detailing or sine of x becoming negative, and once you will be taking its magnitude, actually the minus 0.5 would become plus 0.5, minus 0.25 would become plus 0.25, and similarly minus 1 would become plus 1. So virtually speaking, the change is supposed to come only and only the reason where the worth of the sine of x had become negative, and once you'll take its mod, it would just get flipped. Why I'm saying it would just get flipped? Because the minus 0.25 is going to be plus 0.25, minus 1 is going to be plus 1. So obviously, virtually speaking, they had been getting flipped. Or I would say, this has been minus 1, it would get flipped to plus 1. This has been minus 0.5, it would get flipped to the plus 5. This has been minus 0.5, it would get to flip to the plus 0.5. So magnitude of sine of x, how it would look actually. This is going to be something like this. This has been the lower region, again would be shifted towards upper region. This has been a lower region, again would be shifted to the upper region, and there would not be any change for the intermediates. So I can say the magnitude of sine of x is going to be in this fashion. So Green's curve is being the curve for magnitude of sine of x, or absolute value of sine of x. Yes. And you yourself would be able to understand the cusp is being framed at x is equals to 0. So rather taking sine of x, if you could have taken sine 2 pi x divided by of L, hardly there would be any change. Hardly there would be any change. But still, if the function is being bit complex, they could have designed a better question. If you want, I can explain which kind of the question they must have been designed. But at least at x is equal to 0, it had been clearly known. The cusp is been formed, and as the cusp is been formed, the function would be non-differentiable. But as far as the continuity is being concerned, the function is being completely continuous in entire region of x. Is that clear? Part clear? Okay. This is all about the today's class. We will meet in tomorrow's class. Till then, bye bye. Take care.